This is John Black, Super Chemist, here to show you how to get anhydrous magnesium sulfate. You can get it anywhere. They usually call it Epsom salt. Uh, it's a type of bath salt. You put it in your water and maybe soak your feet or whatever in your tub. Uh, Here's the molar mass of anhydrous. Here's the molar mass of the water that it contains. It contains 7 water molecules. It's a heptahydrate. Here's the molecular weight mass for monohydrate, pentahydrate, anhydrous. It is slightly soluble in ether and alcohols, glycerol. So if you use it to dry alcohol, you are getting a little bit in your alcohol, so you should distill it afterwards. It's insoluble in acetone. You can basically get this anywhere. You can get it at Walmart, department stores, grocery stores, maybe even hardware stores. It's usually in a where the hydrogen peroxide is, or the rubbing alcohol and the toothpaste and stuff, cotton balls. You usually find it around there. It can be in anything. It could be in a bag. It could be in a box. You know what I mean? It depends on what store you go to. But it always says Epsom salt on it. And you can just ask anybody in that department. They'll know exactly what Epsom salt is. Mainly, I use this as a desiccant, but there are other uses. For seven waters, that's a lot of water. I mean, it almost absorbs this. Actually, absorbs more water than it actually weighs. If I have 120 grams, I can absorb 126 grams of water. Now, the Epsom salt, the mineral that Epsom salt comes from, is called Epsomite sulfate mineral. So you can see why they call it Epsom salt. But the big question is, since you're buying it and it already has water in it, how do you make it anhydrous? Well, if you want a monohydrate, you'd put it in the oven, maybe, a little bit, like a half-inch or quarter-inch high, and spread it out, and you would put your oven on 150°C. That will get you a monohydrate. You just wait until all the water evaporates. Now, if you want it totally anhydrous, you got to go to 200°C. But the problem with that is, at greater than 200°C, okay, 250 to 1000°C, you will get decomposition of your magnesium sulfate, and you'll have magnesium oxide, sulfur trioxide, and oxygen. And if it's really hot, your sulfur trioxide will turn into sulfur dioxide and oxygen. But even though it says 250 to 1000, at 200°C, there is some slow, very, very slow decomposition, very slow. But this is some nasty stuff here, okay? So you don't want that. My suggestion would be to go in between here at like 175. And I think that correlates to about 350 degrees Fahrenheit. Normally I do mine at about 300 Fahrenheit. I'm glad I did this video because now I'll jack it up. I'll jack it up to 350. When I say 350, I'm talking about Fahrenheit. So keep that in mind. Basically, when you put this in the oven, it'll turn into a big pile of liquid, and you'll have a saturated solution of this. And you just have to keep heating it up and let it evaporate until it's total powder, and then crunch it up into little powder, so you know that all of it's gone. If there's any crystal left, and you know that it's not gone, all the water. All right, let's recap here. You got the first thing you're going to do is buy the Epsom salt at a drugstore or wherever, Walmart, whatever. If you want, you can recrystallize it. I don't think it's necessary, but you could. Then once you recrystallize it, throw it in the oven at 175°C. Keep powderizing it and letting the water evaporate until it's all powder. And then you're done by weighing it. And if you ever weigh anything hot, you need to put a pot holder down on a scale, zero it out, and then put your hot stuff on top. Otherwise, you'll screw up your scale. But here's how you figure it out. Now look, this is pentahydrates, how much it is gram per mole, and this is anhydrous. So I divided them to figure out the percentage. There's 48, and you can see it's half. 120 and 120 is 240. It's slightly lower than 50%, right? 48.8%, all right? So all you have to do to know how much it's going to weigh when you're done is by multiplying what it weighed to begin with times 0.488. So if you start out with 246 grams, a whole mole, multiply that by 0.488 and you get 120 grams. And that's what it is. If you have 100 grams, multiply that by 0.488, you get 48.8 grams. That's how much you should have after all the water's gone. If you end up with 55 grams, you didn't get rid of all the water. You end up with 49.5, you didn't get rid of all the water. This will be exact because I always weigh my stuff when I do this kind of stuff. And it always comes out exactly. 200 times, that's what you get. So whatever you have at the beginning, multiply it by this. Remember, always weigh up your pan before you fill it up. Because once you fill it up, how are you going to zero it out? How are you going to, you ain't going to know what that pan weighs. Even if you have an identical pan, I can guarantee you they don't weigh the same. Okay? So you got to weigh that up first. That way you can figure it out or zero it out or whatever when you're weighing up your to see if it's done or not. You know what I mean? Keep in mind, when I draw something out, this is my go-to thing, man. Magnesium sulfate. I did buy some molecular sieves last year. I didn't even use them because I'm so used to this and I have so much of it. But I haven't found anything it's incompatible in. I'm sure there are some things that it is incompatible in. But if anyone knows of anything it's incompatible in, let me know. What are the uses for this? And I'll get into that next. All right, so here's a couple ways you can use this. You can, and I've already done these right here. Magnesium sulfate, put it in with some base. Magnesium hydroxide, just like how we make chromium hydroxide. It's insoluble, or almost insoluble. It precipitates out, and you can filter it. You know what I mean? Then you can take that, and if you add enough heat, you'll do a calcination, drive the water off, and you'll get magnesium oxide. What good is that? Because I want magnesium metal. Then I can do like a thermite reaction with aluminum or something and get my magnesium and my aluminum oxide. Now keep in mind, I don't know if these are correct, these equations. I mean, they're close. I didn't look them up is my point. So they might be slightly off or something like that. But this is the gist of it. I actually didn't do this thermite reaction yet. I did make the magnesium oxide. But another thing is electrolysis. See, electrolysis of magnesium chloride is the best way to go with electrolysis to get the metal. Okay. Now, how do I get magnesium chloride? Well, this is another method of making stuff with this magnesium sulfate, because you can get any calcium or barium salt and it will match up, because the whole point is calcium and barium sulfate. Neither one of them is soluble in water, so they will precip out. Okay, so if I get calcium chloride in these two, the calcium sulfate will precip out, and you'll be left with magnesium chloride. Okay, now if that was calcium nitrate, you'd be left with magnesium nitrate. If that was calcium, whatever. The point is whatever, these two are going to match up. And then another way that magnesium sulfate is good for is because it can get you magnesium salts. I showed how you get the magnesium hydroxide. Then you just mix it with any acid you want. If I wanted a chloride, I'd do it with hydrochloric acid. I want a bromide, hydrobromic acid. I want sulfate, sulfuric acid. But then you can put your base and acid, and what do you get when you get acid and base? You get salt water. So you get your salt water. One more fact I want to mention about magnesium. I am a terrible speller, and magnesium is one of the few elements where there's only one S. So magnesium, where that S comes in, cesium, there's only one of them, one S. That's about it for magnesium sulfate. I'm going to have a great day, and always remember, science is great.